Today in class 11th, I have a discussion on the vertical circular motion. Now, this is now like this, that I have taught you about the circular motion in the vertical plane and also in the horizontal plane. So here I am taking the general discussion on the vertical circular motion. It is non-uniform circular motion. Now here, if we are having the speed that is to be constant, then this may be the example of uniform circular motion. The forces acting on particle in vertical circular motion are: number one, the tension T in string. Number two, weight mg. And number three, centripetal force. This is now mv square upon r. The centripetal force is always directed towards the center of the circular motion. The critical velocity at topmost point, this is equal to square root of r into g. The velocity at lowest point. This is equal to square root of 5 Rg, and the tension at highest or topmost point this is now this T2, this is equal to 0, and tension at lowest point is T1, this is equal to your 6 mg. This I have told you. The velocity at horizontal points is equal to square root of 3r, and tension at horizontal points, this is equal to 3 m. This I have discussed, and also I have made a general discussion for these velocities when we are having the tension at any angle theta. This is suppose a circle. This is now O. This is now point P. This is now your point Q. These are the horizontal points. This is now Q. This is now your R. As I have discussed, this is now S. And here is the tension. That is now your T1. This is now tension T2. Here the tension that I have told you, this is now 3 mg. Here the velocity at this lowest point, this is equal to square root of 5 Rg. Here the velocity is equal to square root of Rg. Here the velocity is your square root of 3 Rg. Here the velocity is square root of 3 Rg. This what I have told you here, that the tension at the topmost point R, this is equal to T2 equal to 0, and the lowest point is now equal to 6 mg. Now suppose you are given the angle theta. Suppose you are given this is now angle is theta. Here is the particle. It has the velocity v like this. It has the tension T. Then this is now component mg cos theta. This is the weight mg. So at angle theta from the particle, at angle theta from lowest vertical position, lowest vertical position means the point P. This is the angle is given to be theta. So what we have? The tension T minus mg cos theta is equal to mv square upon r. This I have told you. So tension will be how much? If you just solve to this one, then this t comes out to be 3mg into 1 plus cos theta. This is the general expression. General expression. And this velocity v is equal to square root of rg into three plus 2 cos theta. This is so much. You put the value of theta at the lowest point, highest point, and on the horizontal points. You will find the velocity that I have told you just now. The velocity at the horizontal points 3rd. So at horizontal points Q and S, theta equal to 90 degrees, then this is now equal to square root of 3rg. And if you find the tension, then this will be your theta equal to 90 degrees, so this is now 3mg. These are the general formula for this one. Here I have taken that the velocity at the lowest point is square root of 5rg, and that the at the highest point the velocity is square root of 3rg. This is the critical one. This is the one special case. If the velocity is less than this velocity or less than this, there will be no vertical circular motion. If v less than square root of rg or v less than square root of 5rg, there will be no vertical सर्कुलर मोशन। यानी कि अगर वेलोसिटी इससे कम हो या इससे कम हो तो इसमें कोई भी सर्कुलर मोशन वर्टिकल प्लेन में नहीं होगी। तो इसका मतलब यह है कि जो वेलोसिटी है वो क्रिटिकल वेलोसिटी से कम नहीं होनी चाहिए। So the minimum velocity that we require for the motion in the vertical plane is square root of rg. If v is greater than square root of rg or v greater than square root of 5rg, there will be vertical circular motion. So now let us take that what will be the tension and what will be this your velocity when we are going to find to this one. The velocity is more than square root of 5 rg at the lowest point, and this velocity is more than square root of rg at the highest point. Then what will be the value of the tension? For velocity at lowest point v greater than 5 r square root of 5 r. So हम इसको क्या मान लेते हैं? Let this v is equal to square root of 6 r. हम इसको ये मान लेते हैं. Now this is equal to 6 r. Then what will be the tension and what will be the velocity be? If you just calculate it, the tension T minus mg cos theta is equal to mv square upon r. So what will be here? This T equal to mv square upon r plus mg cos theta. Now the velocity, this velocity p, this we have taken, that is more than this 6 rg, square root of 6 rg. So apply the equation v square equal to u square plus 2as. So the u will be this square root of 6 rg, this is now minus 2as, this is now 4 rg. Then how much this will be? This is equal to, this we take suppose number 1. Velocity v equal to square root of how much? This is now square root of 6 rg whole square minus 2 g, and this is equal to 2gr into 1 minus cos theta. So much. So this b equal to square root of 6 rg minus 2 rg plus 2 rg cos theta. So this is now 4 rg, square root of 4 rg plus 2 rg cos theta. This is now velocity v. This we take the equation number 2. And if we put this value here, then what will you find? Now put v in equation 1, we get this t is equal to, just to solve for this one, this r will cancel from all, so this is equal to your this 4 rg, 4 mg plus, this is now 2 and this is now 1, so this is now your 3 mg cos theta. So what do you find? This is more important relation. Here I have not taken the particular case when v is equal to square root of rg and v is square root of 5 rg at the lowest point. But I have taken a general point that the velocity is more than the critical velocity. In that case, you can find the velocity at the highest point, lowest point, and also the tension at lowest point and the highest point. Then what you find? At lowest point, P, what we have? Theta equal to 0 degree or 360 degree. Then this then velocity from equation 2, what we have? This V is equal to theta equal to 0 degree. Theta equal to 0 degree. It's not 2 hours, it's now 6 hours. Square root of 6 hours. And that's the tension from equation 3. T is how much? This is now your 3 and 4, 7. This is now your 7 inch. This is at the lowest point. Then what about at the highest point? At highest point, this is now your, we are having PQ, this is now R. What we have? Now from equation 2, V is equal to, at this point, theta is equal to pi radian or 180 degree. Then what will be here? This cos 180 equal to minus 1. So this is now minus 2 RG. So this is now 4 RG minus 2 RG. This is now here 2 RG. Square root of 2 RG. And that's from equation 3, T equal to, now this is not T, minus this now, this will come out at, this is again the NG. This is not bit. Again you got the difference, 7 NG and this NG, this is now 6 NG. Now again the difference up to this one that you find is here. So what will happen that when we are taking the critical case or we are taking the case in general, the difference in weight at the lowest and the highest point is always 6 cm. Therefore, difference in tension at lowest and highest points, this is equal to 7 mg minus mg, so this is equal to 6 mg. When we are taking the critical case, that the velocity is equal to the critical velocity, there is also the difference in the weights at the lowest and the highest point, that was the 6 mg. So here also we are getting the 6 mg. This means that weight does not change. Whatever is there, this tension, the difference in tension will remain the constant. Similarly, if you find to this one, then in the square root of 2, this is the square root of 6, that you will evaluate and then you can find the difference in velocity also. Now we are taking at horizontal points. और R, नहीं Q और S, Q और S. What we have here? We have theta equal to pi by 2 radian. So now then you find from equation 2, this B is equal to how much? Cos pi by 2 equal to 0. So this is now your 4R. This is now your square root of 4R. Or this B equal to 2 square root of R. And there the tension from equation 3, the T equal to, this is now only this 4 mg. This is now 4 mg. 4 mg. Cos pi by 2 is equal to 0, so we are having only the 4 mg. There was 3 mg, now this is now 4 mg. It means that by increasing the velocity, the tension and the velocity increases at every point. So there is first, when the particle goes from lowest to highest point, the velocity decreases and tension also decreases. And when the particle comes back from highest point to lowest point, the velocity increases and tension also increases. So what we have the conclusion? Conclusion. Number 1, when particle moves from lowest point to highest point, the velocity and tension both decreases, and when particle moves from highest to lowest point, the velocity and tension both increases. So जब निम्न से उच्च पर जाते हैं तो वेलोसिटी और टेंशन दोनों ही डिक्रीज होते हैं, और जब उच्च से निम्न पर आते हैं तो वेलोसिटी और टेंशन दोनों ही इंक्रीज होते हैं। तो इनकी मिनिमम वैल्यू जो होती है वो हाईएस्ट पॉइंट पर होती है, और जो मैक्सिमम वैल्यू होती है वो लोएस्ट पॉइंट पर होती है। The velocity and tension at highest point velocity and tension is equal to minimum both minimum and at lowest point velocity and tension both are maximum. Both are maximum. So if we are having to this one, and if suppose now we can draw one more point, that if the velocity of the particle in the vertical circular motion is more than the critical velocity, then the tension and the that velocity will increase at every point. Now third, for circular motion in vertical plane, angular velocity omega is equal to is not equal to constant. Linear velocity B not equal to constant, angular acceleration alpha is not equal to 0, is not equal to 0, and that's the tangential acceleration at, this is not equal to 0, this will have some value, and that is alpha is equal to d omega upon dt, and here this at equal to I r into alpha, and that's the centripetal acceleration AC. This is equal to V square upon R, and that centripetal force. This FC, this is equal to mv square upon R. Tangential acceleration is there, so there is a force acting on the particle, and that force will be given by this m into the tangential acceleration at, so r into alpha. So tangential force, this Ft, this is equal to mr into alpha. So these are the factors which remain constant and they are acting on the particle. But if the circular motion is uniform, then all this will be equal to 0, this will be equal to 0, and this is equal to constant, and this is equal to 0, and this will be equal to 0, and AC is never 0. Whether the circular motion is uniform or non-uniform, the centripetal acceleration is never 0. The tangential acceleration is always 0. So this is what the difference between the uniform and non-uniform circular motion. This I have told you a general discussion about the circular motion in the vertical plane. So this we have the main things that we have to keep in mind when we are going to solve a numerical question based on the vertical motion based on the circular motion in the vertical plane. So all you pass this video completely. Thank you.